Wow, a time machine. I hope I can use this to help me pass my chemistry final. Hello, my name is Dr. Alfred Werner. I'm a French-born chemist who studied at the University of Zurich. I received a Nobel Prize award in 1913 for my work regarding the theory of variable valence, meaning my ideas explain the molecules, their atoms, and the positioning of their atoms. Due to my discoveries, resonance structures of molecules, the molecular geometry, and the understanding of bond lengths and strengths were able to be determined due to my discovery. Hello, Dr. Werner. I need help with my chemistry final, but do not understand your theory. What are resonance structures and molecular geometry, and why do I care about this? Well, my discovery showed us that molecules can appear differently despite having the same atomic makeup. We didn't know before that molecules could appear the same physically, but have different molecular structure and geometry. I conducted an experiment in 1898 in which I mixed silver nitrate with hexamine cobalt 3 chloride. And I did this experiment with 3 different chloride ions, and all produced the same silver chloride. But what does this mean for me, Dr. Werner? This means that since all 3 different molecules, organized differently with slightly different electron configurations, continue to have the same result in this experiment, meaning that regardless of how the molecules are configured, the result will continue to be the same. Look at these 3 different molecules. All 3 of these molecules depict silver chloride when observed closely. While these seem different, the molecular makeup is the same, just using different ions of chloride in each. These different ions change the electron count and can change the charge and weight of the molecule. But the molecules rearrange to accommodate this in order to remain the same and to satisfy the Van Hoff's rule and the octet rules. These different molecules, while having the same chemical makeup, can be made into a planar, trigonal, and octahedral structure. This alone helps us explain electron geometry and why we see the same visible compound despite how each is organized. Here, look at these 3-dimensional drawings. Each bond, according to its electrons, will have a greater push and pull, resulting in angles changing in order to match one another. Therefore, if the bond becomes closer together at the top, it is because these 2 are stronger, and the bonds adjacent to them will become further apart, meaning their bonds will be weaker. My experiment explained why the silver chloride appeared the same, but the different ions of chloride within the silver chloride would deteriorate and break apart easier. This is because depending on the ion, it would make it weaker or stronger, depending on the charge on the ion. Because being able to determine the link between the bonds can help determine the strength, and understanding the angle of the bonds can help explain how long each bond is between the molecule, therefore determining how strong they are. Discovering this allowed for the future of science to gain a deeper insight, especially in inorganic chemistry, for future chemists to determine how these chemicals will interact with one another when introduced outside of a natural environment. Good luck on your chemistry final. I hope that my contributions to science help.